Hey guys, welcome back from the weekend. I hope you had a good weekend. Today's lesson is going to be Unit 1, Day 9. We're going to be learning how to describe a graph today. So our content goals, we're going to start off with a little bit of review on inputs and outputs of a function using the rule. And then we're going to focus on finding and describing the x-intercepts and y-intercepts of a graph. All right, we also want to make sure that we understand how to write the x and y intercepts as ordered pairs once we find them. All right, so let's start off with our review. We're going to revisit how to evaluate a function using the function rule and order of operations. So watch below. All right, so here we go. We've got a function. Its name is f. The input is whatever they tell us x is. And this is our rule, the negative 2x plus 4. So over here they tell us what to find. It says find f of 7. Okay, so notice that the 7 is in parentheses here, so they're telling us the input. They're telling us what this x value is. That is our input. So we're going to take this 7 that they give us and we're going to replace x with a 7 in the rule. So if I want to evaluate f of 7, then I go into my rule and wherever x was, I replace that with a 7. Okay, that's if they give me an input. And then I use my order of operations to evaluate the function. So I start with multiplication. So I'm going to do negative 2 times 7 first. That's a negative 14. And then I still have that plus 4 on the end. And guys, this tripped us up a lot on the test, was just handling negative and positive numbers. A negative 14 plus 4 is negative 10. All right. If you need to, use your calculator. Make sure you type in negative 14 with the negative button at the bottom of the calculator, not the minus button at the bottom of the or on the side of the calculator. You want the negative that's at the bottom. Okay, and I will demonstrate that on my calculator just in case we're still getting the negative and the minus button mixed up. I've talked about it in previous videos. So for instance, if I want to do negative 14 plus 4, so I'm going to do negative, this is the negative button, 14 plus 4. Okay, this button down here is different than this one right here. This is negative, this is minus. So I'm going to hit enter and we get negative 10. All right, let's try it again. We've got another function. It is also called f. The input is going to be x, and this is our rule. All right, so over here they tell us find f of negative 2. So the input, because this is inside of that parentheses, they are telling us what x is. So that negative 2 is going to go in for whatever x we see in the rule. Okay, so this is going to be negative 2, and I put that in parentheses, squared, plus 1. Okay. This tripped us up a lot on the test as well. Whenever we had to square and negative, a lot of you guys said negative 2 squared was negative 4, but negative 2 squared is positive 4, and then you have that plus 1, and 4 plus 1 is 5, and that's what we're looking for there. Again, I want to demonstrate that on the calculator. When you put this in, when you square something, you have to put it in a set of parentheses. If you don't, the calculator will not give you the correct answer. So we got negative 2 squared just like that. We get a positive 4, but if you don't put the parentheses in, so if you just do negative 2 to the second like that without the parentheses, it'll give you a negative 4. You want the one with parentheses. That is the correct version here. Okay. I said I've talked about that in previous videos. I talk about why that is in the previous video, so make sure you go back and review that if you need to. All right, here number 3 again, we're looking at a function. Its name is f. The input is x, and this is the rule. Okay. Now it says find x when f of x equals 20. So notice the number that they give us, it's not in the parentheses. They actually want us to find the input, and what they gave us here was the output. So to do that, I have to take this entire f of x, the entire left side of the equation. I'm saying I'm going to get out a 20. So I'm going to put a 20 on the output. I'm going to say 20 equals negative 2x minus 10. Okay, I want 20 to come out. I need to figure out what goes in. And we do this using a little bit of equation solving. Okay, so I'm going to add 10 to both sides and start trying to get this x by itself. The 10s are going to cancel. 20 plus 10 is 30. So now I have 30 equals negative 2x. And then to get x by itself, I have to divide, because this is negative 2 times x, and to undo multiplication, I have to divide. So I'm going to divide by negative 2. The negative 2's will cancel, so x is the only thing left, right? So now x is the only thing left on the right-hand side of that equation. And then when I do 30 divided by negative 2, we get a negative 15. Okay? And that's what we're looking for. So if I were to put a negative 15 in for x, I would get out the 20 that I was looking for. Feel free to test it out. All right, guys, so now we're going to start talking about the next concept of this lesson, and that is, what is an intercept? Because our goal is to start describing graphs, and one of the key features that we see in most graphs of functions are the intercepts, and an intercept is exactly what it sounds like. All right, you want to think about the game of football. If you've ever watched football before, we know about this thing called an interception. All right, and an interception occurs when someone from the other team catches the pass. This occurs when the path of the player intercepts the path of the ball. All right, so we're looking for two things to essentially hit the same point at the same time. We call that an intercept. All right, so we're looking for the same thing on the graph, except we're looking for when the function, right, that would be the blue thing here, intercepts the x-axis or the y-axis. So the x-axis is this horizontal line that runs across. The y-axis is the vertical line that runs across. And I want to know, when does this blue function, right, this is our function, when does this thing hit either the x-axis or the y-axis? When does it cross over? So if I'm looking at this graph, I notice that it hits the x-axis right here. This is the point of intercept. Okay, and that happens at a particular coordinate. So for instance, this is the x-axis, so we know this is an x-intercept, and it is located at a point 2, 0. Okay, the y-intercept, right, so this is the y-axis, the vertical line that runs down the middle of the graph. It intercepts the y-axis here at negative 4, 0. Oops, got that backwards. Sorry, 0, negative 4. And believe it or not, that is actually a common mistake that students will make, is they will switch up these coordinates all the time. So make sure you do get them in the right order when you're writing those ordered pairs. All right, and that's another thing. All intercepts should be written as an ordered pair. So a lot of students might be tempted to say, well, the x-intercept is at 2. If you write your answer like this in MyOpenMath, it'll count it as wrong. Some of you might go 2, 0 and forget your parentheses. MyOpenMath will count that wrong. You have to write it as an ordered pair, complete with its full coordinate and a set of parentheses around it. Okay? If you leave any of that out, MyOpenMath won't count it as right. All right, welcome back. So sometimes a graph can have more than one x or y intercept. So we look at this graph down here, and in this graph you'll see that we have 2 x-intercepts, right? So this is our x-axis. Our function is this blue parabola here. So to find the x-intercepts, we're looking for where we cross over this horizontal line that runs through the middle of the graph, and we see 2 locations where that happens. One is here, and one is here. Right? And I'm going to write the coordinate for both of those here where it asks for the x-intercept. Okay, so the first one occurs at negative 2, 0. Just like that. And then I'm going to put a comma here, and I'm going to start writing the second x-intercept, which occurs at 2, 0. So when you enter this into MyOpenMath, make sure you write the full coordinate, comma, second coordinate if you have more than one intercept. Okay, and we're still going to go and find the y-intercept here. Remember, the y-axis is the vertical line that runs through the middle of the graph, and we're looking for where the blue function crosses over the y-axis, or where it touches the y-axis, which is right here. And that is located at at 0, negative 4. And again, you have to write these as ordered pairs, complete with their parentheses. Don't forget about that. All right, guys, last example here. So sometimes there are situations where a graph could have no x or y intercepts, such as this one here. In this graph, we see one y-intercept and no x-intercepts. This thing never crosses the x-axis, which is located right here. You'll see it kind of flattens out and never gets to the x-axis, and that's fine. So for an x-intercept, what we're going to say here is D and E, for in other words, does not exist. X-intercepts do not exist, okay, for this graph. And on MyOpenMath, this is what they want you to write. It should there be a situation where the x-intercepts or the y-intercepts do not exist. Now this one does have a y-intercept located right here, and we're going to write out that point. That is going to be 0, 2, complete with its parentheses. All right, guys, that's it for today's lesson. Hopefully you understand how to find the x and the y-intercepts of a graph. And we've looked at several different types of graphs and several different types of scenarios. Make sure you do the practice problems and ask questions if you have them in the Zoom chat. Have a great day.